Hi everybody, and welcome to week 10 of CAD1134. Today we're going to be talking about advanced dimensioning and layout. Today we're going to be reviewing viewports, views, the sheet manager, dimension style manager, template creation, dimension types, and tables. A lot of these are repeats again from previous weeks. That's because they're really important, so we're going to keep driving over it over and over again so that you're assured to get it. New material for this week, we're going to talk a little bit more about projected views, section views, part selection, detail view, first and third angle projection, which you should already know about, but we'll talk a little bit more about that. Tolerancing an introduction. And finally, we're going to talk about exporting and rapid prototyping and how that has really helped our industry along. Okay. So as a reminder, from last week, I believe, we talked about creating viewports. And so in order to access this, you need to be in your layout mode, and then you're going to create a rectangular viewport. Remember when I made this, how I did it was I created a rectangle and then I made lines from the midpoints, and then using the rectangular viewport, I picked this corner and then this intersection to create each of my viewports. I then went in through model space and changed the view, top, front, side, and then I created some isometric view. Now, you can see that these are very clean and neat. They rendered up very nicely, and that is the main advantage to using viewports, is you are able to render them very nicely. The downside is that this takes a fair amount of time. It's difficult to line up this edge and this edge, right? And the other thing is that it's easy to lose the reference, to lose the association between a dimension and the geometry this way. So everything has its place. This is absolutely wonderful for creating a isometric view or some detail view that you want rendered to be very clear to the viewer, but it is difficult to dimension and work with. The other way to create a layout is to use the base, and we can easily lay out perfectly aligned geometry like this. So here's my valve bill. So we're looking at the front face, the bottom face, and the side view. And the nice thing about this is it does do the first and third angle projection automatically for us, so we know that it's right. In this case, that the top ends up at the bottom, so we're taking that part and we're flipping it. So that's third angle projection. And we're able to lock the view so that we don't lose the association of our dimensions as well. However, if we try to use a rendered view on these, you'll find that it kind of is reminiscent of the 8-bit realm. So you end up with this kind of blocky resolution, and that's okay if it's good enough for you. If you want something better, then you can absolutely put in a viewport. That said, there's nothing to prevent you from mixing and matching. So you could use your base layout and for your isometric view, put in a viewport. All right. From week 7, we talked about the sheet manager. It becomes very important now that we're starting to have multiple pages of layout. So the way to access that is you're going to go under Layout. You go to your page Setup, which opens up your Setup Manager. In here, you can create new tabs, or you can modify the existing ones. And so if I click on here, I can actually modify it and change some of the parameters. So why don't we do that? I'm going to use my capstone project as our example today that we're going to work through. And so let's take a look at what's going on here with our layouts. And so when I go over to my layout tab here, it appears that we're actually have our layout ribbon, but we don't. We're actually in annotate, and we can tell because it's highlighted here as annotate. And so when I click over here on layout, notice we get this change. And one of the things is this page setup. Page setup actually gives us quite a bit of stuff to work on. And one of the things that we can do is we can actually modify our paper size while we're here. We can also go ahead and create some new setups. And so in this case, I'm going to create a new setup called 11 by 17. And in here, I'm going to change from ISO A4 to an SI B size. Okay, so it's the imperial equivalent, kind of. And I'll say, okay, so I've got two of them. This one here we can modify. We'll make sure that it's set up as, oh, that one's set up as 11 by 17. Let's go back and change this, rename to 8.5 by 11. And I shall modify it to letter 8.5 by 11. And so what this does is it means that I have two setups available to me that I can very quickly change between. So 11 by 8 there, perfect. And so here we are. I'm looking at my cover, and so perhaps I wanted to see that in 11 by 17. I can simply select between these two page layouts. And as you can see, there was actually quite a bit of stuff that we can modify in here. And so this is a very powerful tool. For example, if I wanted to print it out, that I wanted this page to always be in grayscale, I could do that, right? Let's say, okay. What else can we do with this? Well, when we go to our pages, we can literally change each page manually as well by changing this page setup. So in this case, I'm in assembly. I can modify assembly, and so it's not really associated with anything, but I'll make it some weird size. There you go. Some big thing. And so it only affects this drawing. All of my other drawings are still the way they are intended. So this is a great way to have standardized formatting that you can update across the entire drawing. And so as a reminder, instead of being in layout, we need to go over to annotate. And then you're going to go to this little wee guy here, annotate, dimension manager. And in here, remember that you should never modify one of your base dimensioning styles. So you'll create something new and you can copy it from an existing one. And so let's continue. And so this is a copy of a copy. You should actually give it a proper name. But you can see we can set the primary and secondary units. We can deal with the precision. We can deal with the position of the dimensions. And we can also play around with symbols, arrows, text style, text height, all of that. And so if you are doing a proper layout, being my CAD is in model space and my drawing is in paper space, then you shouldn't have to play around too much with this. It actually will give you, in this case, the height of the text being 2.5 millimeters, because this is an imperial drawing, is spot on. If you want something bigger, you can absolutely modify it here. but you do want to be careful not to make your text too big. Okay. So next, we want to talk about templates. I want to draw your attention to the template that I've been showing off here. This is analogous to a professional template. This is what you would use in industry. The little grid markers around the outside, if you've ever worked with topographic maps, it looks very familiar. And the reason why it looks familiar is we can actually specify information using these grid markers. For example, I want to draw your attention to this item here. I could say that I've modified the hole at location G6. And so you'll look for G and 6, and you know that the area that I'm referring to is here. This should belong in your template file, and there's nothing that says that this has to be, 25 millimeters or 30 millimeters. Typically it is 25 millimeters or 1 inch, but it can be completely up to you. And by putting this in your template file, you do it once and it's there forever. My suggestion is you do the 11 by 17 and then modify it for an 8.5 by 11. And that way you have it for all time that you can go at and modify it. The other thing that you're going to want to put in and kind of have it there forever is a revision history or revision table. Okay. Now this is where I'm referring to the zone. So in this case, the part was created. It's everywhere. But if I make a modification, I can specify zone 7G and I'll know where to look. Do keep track of your template files. You're going to want to keep it in the library with all of the blocks that you've been creating. And so you'd never have to create them a second time. Okay. So next, we have some dimensioning styles. The thing about dimensioning styles, it's supposed to be a review. We didn't really cover it that well in the previous weeks, but I would like to take some time to discuss it with you now. There are several dimension styles, and you are allowed to mix and match to an extent on a drawing. Let me give you some examples. An angled dimension can absolutely go with any other dimensioning style. Okay. And so here's an example. Here's another example where I'm dimensioning a geometric feature to a theoretical feature. So I've this phantom line here is representing a vertical line, right? And I'm saying that this pentagon is 36 degrees canted. So that feel free to do something like that. It's more clear than trying to call this dimension from here over to this edge. I mean, you could, but this also could be a theoretical line between this hole and this hole. Nothing says that it has to be relevant to any other geometry either. It should be, but radius and diameter, definitely two things that can be placed with any dimensioning style. So feel free with that. This is called orthometric. Orthometric is great because it is based on a 0, 0, and typically 0 point. And for the machinists out in the shop that are working on this, this is really handy to punch in manually, because they will simply zero their machine out so that their cutter is in the middle here, and they'll move up 3.71 and then move over 2.61 and drill that hole, and then move up to these points. And so they have a digital readout on their machine. They can just wind it in and punch all of these holes. The downside is this is a pain in the butt to set up. It does use the global coordinate system, so you need to play around with that a little bit. There's a couple workarounds, but just be aware of it. One thing you don't want to do is to start to mix the orthometric with any of these other dimensioning styles, because it gets really confusing. You could do a whole pattern like this and then give the absolute dimensions of the block. That we could live with. The next here is a base dimension. So in this case, this is a base dimension. It's very similar to the orthometric, but you can see that each geometric feature is based on that 0 and moves across. Continued would be like this one, and this just really is a way to expedite your dimensioning. And so in this case, I'll pick the first dimension, and then I will say continued, and then I'll pick the next one, and it assumes that this last point is your base, and so it just moves across from one to the other. Linear dimensions are, as they say, linear, so absolute in the X or the Y. In this case, it's a perfect example where I have a sloped line, and I don't really care. I'm measuring the width of that sloped line, so across not the hypotenuse, but what would be the adjacent. Now, this one here is aligned, so this is an aligned dimension, and it absolutely measures the line that comes across here. So if we were to make this a right angle triangle, it's measuring the length of the hypotenuse. Okay, so these are the types of dimensions that are available to you, and how you use them is completely up to you. All right. Now to create our revision table, the proper way to do this is to use the tables menu and to select it, size it, scale it, all of that fun stuff. And I know it's a pain, but it is the correct way to do it. The reason being is that you can easily add fields to it or modify it. There are two other techniques that you can use. One is to copy and paste out of an Excel spreadsheet. That's somewhat problematic. The proper way to bring in an Excel spreadsheet is by use of an OLE object, but it has to be done properly. And I'm not going to go over it this year, because I would really like you to do it the correct way. The use for an actual spreadsheet in here would be for calculations. So things that the fields aren't going to change on very much on a regular basis. For example, if I were calculating some forces and I wanted to show this in my drawing, or if I had a field of numbers that were represented from the manufacturer, maybe the dimensions of a part, I could capture that and bring it in. Okay. Next. Okay, so we're into some new material. If you haven't already read the orthometric projection and multi-view construction, I highly encourage you to read it so that you understand exactly what we're talking about when we talk about different views. And you should really understand how these 6 views work. Okay. Let's take a look at my CAD again. I've got myself a new layout, and I'm going to create a base view. And here's my part. I'm going to scale this down, quarter scale. And so I'm going to call this my base. I'll press enter. And so what are the 6 views? And so we're going to call this my top view. I've got the front, I've got the back, I've got the left, I've got the right, and then I have one more view, which will be the other side of it. So one thing that we can always do is to create another projection view from a projection view. So in this case, we're looking at all the views. And if we were to imagine moving these all together and cutting them out, I should be able to create a nice little cube out of these. All right. So if I were to do something like this, and you can imagine if I were to create or print this, I would be able to literally fold it up and create a cube that would show this. As a matter of fact, why don't I do that? I'll be right back. So there's our 6 views, and as I said, if you haven't read the orthographic projection and multi-view, do that. Make sure that you are familiar with it. It's going to be very important. Okay. Now, so we're going to create a part selection with the base, right? So this is this becomes really important. So here I have my assembly view. Oops. Let's change this back. So we go to page setup. We are looking at our assembly view, and we're going to set that to 11 by 17 and close. Okay, so here's a great example where I have a view that I want, but I don't want to necessarily see all the parts. Here you go. This is better. All I want to do is see that front cover. And so how do we do that? So what I'm going to do is I'm going to create a new layout. I'm going to get rid of this viewport, and I'm going to say create from base or base from model space. And before I even select here, I'm going to go up and I'm going to choose model space selection. Okay. And it takes me over to my CAD. And let's say, for example, all I wanted to look at was the power supply. So I can deselect everything by holding the shift and windowing it. And then, and this becomes a bit of a trick, I'm only going to select the power supply inside. And then I'll press enter. And now I have just the power supply. If I wanted more items, I could pick them. That's not a problem. But here I'll go 1 to 1 because this is going to be fairly simplistic drawing. And let's say that I want to see the, so if this is looking at the back, I want to look at the right side. No, left side. There we go. Left side. Try again. Try that top. Nope. Should be the right. Okay, we'll go with that. So there we are. We're looking at the right, and then I'm going to look at the side, and then I'm going to look at the top and throw in an isometric view. I'll press enter, and ta-da! Everything is brought into place. Only the items that I wanted. And so this is a great way to start to pull out details. And you see that it's actually quite easy, and we can actually go back and modify that. So let's say, for example, I also wanted that grommet for whatever reason. So I'll select it, and then I'll press enter, and it brings me back, and now I have the grommet and this power supply. Completely irrelevant, but so be it. We can also change, at this time, we can always revert to different scales. We can also change globally on our sheet what our sketch is going to be. So in this case, I'll turn off the hidden lines, so only the visible lines are available. And you can see it really quickly makes it easier to read. Right? You can look at this and understand what's going on. Okay. So that's fantastic. We can turn things on and off. And of course, in Paperspace, you're going to bring in your title block and what have you. And the way to really do that is to go, instead of saying new like this, we're going to say new from template. And I'm going to choose my template, which I called Scott. And I want drawing of a hatch. It happens to be the tab that is the correct one, which here we go. Now, yeah, let me get rid of my viewport. Fantastic. The next thing that we want to do is I want to show you how to select different components if we're using the rectangular layout. So we're going to go into our rectangular layout, and I'm going to choose some size like this, and I'll pick the left view. So let's say I want to dimension just this face of this feature. And so how are we going to deal with this? The first thing is that we're going to go into our Paperspace, and we're going to go to our layout manager. Okay. So we need to go to, let's just go home, layer properties. And in this case, we're looking for our viewport visibility. Okay. Viewport. There we go. It's way over here. And so in this case, we only really want this guy, okay, which happens to be on layer. Come on, you. Layer 1401 AAA. Okay, so that'll be this yellow layer. So what I'm going to do is I'm going to turn off all the layers that I don't want or need. There we go. So that's turned all of them off, and we want to turn on, shoot. There we go. We want to turn on just the layers that we want. Okay. There it is. Brilliant. Okay. And what else can we do? Well, in here we can change, go back to Paperspace. I'm going to change my view style. So I'm going to go to view. I'm going to go to visualize. Where are you? 3D basics, visualize, and set you to 2D wireframe. 2D wireframe. All right, so notice that when we go back to our model space, it is actually still in my shaded with edges, but in my layout, it's here. One thing that you're probably going to want to also do is at the same time, when we go choose our layer properties, we go back to our layer properties manager. One thing that you probably want to do is change the viewport color. So yellow is great when we're in model space, but it looks quite horrible here. So we could actually set it to some gray if we wished. All right. There we go. Okay. So the problem here is that the color is set to a fixed color as opposed to by layer. Make sure that you do set your stuff to by layer, and it will make things a lot easier for you to change the colors and properties as we work. And so in this case, our color is now set to green, and we're going to set this to red. And even here, we seem to have some issue. Here we go. So it needs to get changed here from green to, let's say, a dark blue, and I'll say OK. And that's perfect. Okay, finally. So the trick is that you need to be in your layout. Set it to model space, and then you'll be able to change it. So it's blue here, and when we go back to our model, it's still green. Okay, or you could change it to yellow, back to yellow if you wished. There you go, nice yellow part. And we go back to a drawing of a hatch, and it's still blue. So yellow and blue. All right, so changing colors for viewports, absolutely essential. One thing I don't like to see is kind of these light colors on the white. It really doesn't work well. And any of these that actually have colors as opposed to being set to by layer, you want to be aware of that. And there is an opportunity, there are situations where you do need to change the color of certain components that are on a layer, and that's fine. I get that. Okay. So what's next? All right. So my box here, I wanted to look inside it, but I have a top, I have a bottom, and it's not really very, very friendly for me to see, to take one part away. So how do I peer inside my drawing or my box? And so let's get my AutoCAD back up here. And here's my assembly, for example. And I want to basically take a slice through this and look inside. And so let's grab another layout here. I'll delete this. And this is much easier. I'm just going to show you how to do this using the base mode because it's so much easier. We've got the my layout. It's perfect. And what I'll do is I will actually leave it like this for just this moment. And let's say I want to look at it through here. I want to see how the back side of this is going to look. And so what we want to do is we want to go into the section view, and we're going to choose what we want to section. And in this case, it's this drawing. And then we're going to create a line using this. For me, it's EE. For you, it's probably AA. And I'll turn my orthometric on so that it snaps to the right place. And I'll press enter because I only want just a straight line. And then it asks us which way we want to look. So if I pull it to this side, we're looking to the that way. If I push it over to this side, we're looking that way. And so determine what you want. In this case, I'll click here. I'll click here, and I will pull this over to where I want it. Okay. Notice that I can move it anywhere along that axis, but I can't really move it up and down. And I can see that I've cut through some of my geometry, so that's not really what I wanted. So I will literally move this back just a pinch, and now I get the view that I want. Okay, and we can see here I have a beautiful section. I can see the hatching of where I've cut through. I can see my power supply is not sitting square, but yeah, okay. I can see that I need some clearance possibly for that drill hole. And yeah, I have an artifact left here from one of my tabs, but this is a great way to look at a detail view. Cross sections are also a very useful engineering tool. Here you can see two elbows that I've created. One of them has a bulge out the side and the other doesn't. The one on the right is easier to mold, but the one on the left you can see has a much better cross flow section. And so being able to take the CAD and actually cut it in half so that you can measure the inside area is beneficial for calculations as well as demonstrations, as you can see here in this example. Great segue into detail views. Perhaps I want to have a little bit more information on this switch. I can go in and use the detail view, and there is a pull down, and I can choose a rectangular or circular. It's up to you how you want to do this. But the idea is that you're going to select where you're picking your view from. In this case, I'm going to pick from here, and I'm going to create a little circle that encompasses the information that I want. And then I will place that detail somewhere on my drawing and press enter. And so now I have a one-to-one drawing of this. I could change it. Okay, don't change it here. I could change it, the scale, for example, to 2-to-1. Okay, so now it's really big. I can also change the actual dimensions or the field that I'm magnifying. And so here you go. Here's a beautiful little example of my blown up switch and how it's going to mount magically. All right, and so there we go. What else do we have? Ooh, right. This is a big topic. Tolerancing. So what is tolerancing and how do we get to it? Let's start with the next slide first. That is what is tolerancing. And tolerancing is a way for manufacturers to be assured that parts will fit together. Why don't they just make everything perfect? The answer is manufacturing itself has some deviation. For example, I have a block here and I have a pin. The block has some dimensions associated with it, and the pin has some dimensions associated with it. But I want this pin to always fit into the hole. Okay, so I need to tolerance this, that when they drill the hole, I'm allowing the drill to wander a little bit so it can get a little bit bigger, but never smaller. And I'm dimensioning the pin that it can be ground or turned a little bit smaller, but never bigger. And the idea is that I always want the pin to fit in the hole. Okay. So we're going to go back to the previous slide here. How do we create these dimensions? What we need to do is the same as when we created new dimension styles. So I'm going to go into my annotate. I'm going to go to my pull down for dimensions. I'm going to create a new dimension. I'll call this tolerance. And I'm going to create it from a copy of ISO 25. It doesn't really matter what you do, but you should create a new one based on the existing style that you're using. And I'll continue. And here we have several tolerance styles to choose from, including precision and what have you. And so right now we're set at none, but we have several dimensioning styles that we can choose from. And I'll go to the next slide and explain what they all are. But let's just set symmetrical for right now. And we can start to throw some precision at it. For example, we have a tolerance of 0.05, which is quite tight for metric. And we'll leave the rest of it, but we can change the positioning and what have you. And as far as alternate units, maybe we put it below. Here we go. I'll say OK and set this as my current and close. Now when I throw a dimension in, let's throw a linear dimension across here. From there to say there, sure. And now it automatically drops in the dimensioning and scales it. So in this case, it's 4 inches plus or minus 0.02 of an inch, or 100.6 millimeters plus or minus 0.05 millimeters. So easy enough to create dimensions, tolerances. By the way, notice that this little icon came up, this exclamation mark, saying that my dimension is disassociated. This happens from time to time if you don't actually click on a piece of geometry or if you move your geometry. So why don't I take a moment and show you how to correct that. The way to do that is to select the icon and reassociate it. And you'll notice this little X, and it's telling me what it's trying to associate. So in this case, I'm going to pick an endpoint. Endpoints are great because they are hard geometric features. Okay. In this case, I'll pick this other endpoint, and it should have fixed it. But the issue is that I'm trying to pick a feature that's based on my cross section. So instead, if I reassociate this with, say, the midpoint here, let's do this over here at this time, so it'll correct it here and here. These are hard geometric features, and so this time it doesn't give me that error. Okay, so if I needed to dimension this, I'd probably use an end view as opposed to the cross section and trying to pick up these hatched lines. All right, so back to our next slide here, where we're looking at the tolerancing. Each of these tolerances has its place and its purpose. Some of them are liked, some of them are loved, some of them are hated by people in the shop. It really depends on their state of mind in manufacturing and what it means. So I'm going to give you my interpretation of what it means and why I use certain things in certain places. Okay, so let's start with basic dimension. Basic dimension is theoretically perfect, and a great example of that is this 90 degrees. I assume that we actually have a right angle. Okay, so, symmetrical tolerancing would mean that we have a tolerance of plus or minus some value. And so here's an example where I have 50.2 millimeters. And so 50 millimeters is nominal. And it means that they could make this block a little bigger or a little smaller. So it could be as big as 50.2 or as small as 49.8. And it would fit my build intent. The other dimension, however, I made it a little bit tighter. And this is a deviate or limits. And so I'm saying this block needs to be between 49.9 and 50.1. So another way to word this is I could have said 50 millimeters plus or minus 0.1, but the nominal may lie somewhere in between. Okay. Now we have deviation, where the upper and the lower are different. And so in this case, I have a hole with a nominal diameter of 10 millimeters, and it is plus 0.2 minus 0. Meaning if the hole is any smaller than 10 millimeters, it would not be accepted. And if it was any bigger than 10.2 millimeters, it wouldn't be accepted. I also have the pin here. Now the pin has 2 dimensions. One is not stated with any tolerance, but the other one has some limits set to it of plus nothing and minus 0.2 millimeter. The reason for this is that I can pick any part. So if I had 1,000 of these and 1,000 of these, I could pick any 2 of them, and I can guarantee that this pin will always fit in that hole. And this is important in manufacturing. What people don't like to see when they're machining these is this 10 millimeter nominal dimension. They really like to see, this plus and minus bit. And so, but I don't want to put in that I want this whole nominal 10.1 because somebody will go off looking for a 10.1 millimeter drill. It's the same as this pin. Perhaps the pin is going to be ground stock. I want to make sure that if anything, it's just a little bit smaller. So I don't want them going off machining every part to 9.9 millimeters just because I need to ensure these tolerances. Where I don't have a tolerance associated, one thing that we usually do is down at the bottom somewhere in your title block, there will be a note that says, unless otherwise specified, all dimensions are to be plus or minus some value. This ensures that somebody doesn't just saw cut a piece that needs to be more accurate. All right. The next thing that we need to talk about is exporting. So we saw how vital it is to import drawings. We also need to be able to export drawings. Now, AutoCAD is very versatile. It can import a lot of things and it can export a lot of things. Now, one of the things that we would like to export is, obviously STEP and IGES and DXF, which is the 2D kind of standard for all CAD systems. But you also want to be able to output an STL file. STL files are great because that's what 3D printing software uses. And so we have available to us a Cura, which is a software that can read an STL file, and they call it slicing. So they'll take a solid piece of geometry and slice it in layers so that it can print it. And we're going to talk about 3D printing here in a second. So what is 3D printing? 3D printing, or FDM, is a machine that will take a plastic filament and melt it and lay it down on a bed. And here you can see we have an example of a very inexpensive 3D printer that we actually have at the school. It runs off a computer power supply. It has some inexpensive servo motors. The spool is elevated here, and the plastic will spool down through this set of teeth into the melting region and be laid on the bed as the bed moves back and forth. The carriage, or the heating head, actually moves up to give us actually 2.5D machining, meaning that it doesn't typically move in the X, the Y, and the Z at the same time. It'll move X, Y, and then only the Z. And these are fairly inexpensive machines, and they will allow you to produce low quality parts, which are fine for looking at maybe some light testing. Better machines can do better jobs. And for example, I had this one here. This part is something that I made for a consumer appliance some time ago, and it was actually injection molded. So there's the finished part, and you can see that the two halves match up perfectly. I was able to create the CAD, and we made the mold, and they fit together. That's fantastic. It meant that we could actually do some flow testing ahead of time, make sure that it did actually make the improvements that we wanted, and save a ton of money in producing a mold if it didn't work. But we're not limited to just making plastic parts, or even for that point using FDM. There are other technologies available to us, including SLA, including laser sintering, including wax printing, so that we actually print in the wax and then put it into sand, and then we can pour metal into it. So it's kind of a lost wax process. This is how they make things like Super Bowl rings, where we don't want one of them, we want 100 of them, but not thousands. So we're not going to build an investment casting die. It's become so cost effective now to do laser sintering of metals that we're seeing production parts now for medium volume things like I know camping stove, there's a little insert that the only way to cost effectively manufacture this little part is to laser sinter it. And so that's a fantastic little piece of technology. Apparently the one of the German automotive manufacturers was making car parts at one point for testing before what they call the buck car, so the test car before production. And there's also SLA that uses ultraviolet lasers to cure the material, so it's a photoreactive material. And so lots and lots of different things out there to provide different niche markets. Some plastics are rigid and hard. For example, there's a carbon fiber reinforced FDM that boasts a stronger yield strength than aluminum, or flexible, that you can actually make living hinges out of other components. There's also what they call digital materials, and so we can have 3 or 4 different types of material, and we can vary the mix of these materials as we're printing the part. So I have something very rigid and strong at one end and something soft and pliable at the other end, or something blue at one end and something green at the other end. And so we mix the colors as we're printing. All right. Homework assignment. I know that you struggled with last week's assignment, week 8. And I promised you that we would spend more time making it better. And so this week's assignment is to take your layout from Lab 8, and I want you to change the layout to B5. And I appreciate that you won't be able to print it on most printers. That's okay. You're going to give it to me in a PDF format, so it's irrelevant. And I want you to add some layouts of the assembly and the lid of the box. If you happen to put all your buttons and display in the base as opposed to the lid, that's fine. But I would like then the detail of the whatever has the most holes in it. Okay. And you'd need to dimension all of these features. I want you to really get in and practice some of that. As an added bonus, if you can give me the projection view down at the bottom, that's great. That's fantastic. That shows me some enthusiasm. It should actually live in your template file, probably as a block, and so you can insert one or the other. And if you haven't done so, do read the documentation on projection views. You don't have to do any of the assignment, okay, the lab assignments in there, but do read through. I need you to understand that because it's going to be important for your tests and your project coming up. Okay? If you're having any trouble, any difficulties at all, please send me an email. If you're falling behind, this is week 10. We've only got 4 more weeks. And so we've got one more main lecture We've got a week of this intended to be a work exercise, and then we've got our project is due. So in week 13, all of your capstone stuff has to be into me. And then week 14 is our final assessment. So, if you're not already there, it's crunch time. You need to make that happen, and we'll get going on that. It's not too late for you if you haven't started your capstone project, but you really should be rubber meets the road this week. You need to really motor along. And the reason I say that is the next few weeks, it's not just my class that is going to have a lot of material due. You're going to have final evaluations in all of your classes, all of your projects, all of your homework. Everything's due. So, take advantage. If you have a few minutes now, get onto it. It's not a time to procrastinate. It's a time to get busy. All right. Have fun with today's project. I hope. I know that it is a bit of a daunting homework assignment. Do your best, and like I say, send me an email if you have any specific questions. And if I can't answer it, I will do my best to research it and get some information back to you, and possibly create a short little how-to video, because if you're having trouble, possibly others are as well. All right. Thanks, and have a great day. Bye now.